So today I'm going to solve number 169, which is called majority element. Given an array, nums of size n, return the majority element. The majority element, which is the number in the array, appears more than n divided by 2 times. And there is at least one number is majority element. In other words, the majority element always exists in the array. So one possible solution would be using counter. Count the number of occurrences of number, and if it is the largest, that is the majority element. That would be simple. However, there is a follow-up question which said that could you solve the problem in linear time and in of one space? Since using counter is already of n space, maybe we need another solution. So I'm going to use an algorithm called Boyer-Moore's boring algorithm. So I'm going to explain in details. When we see the example 2, the total elements are 7 and majority element is 4 since it is 2, and all the other elements sum is 3. So it means that majority element is always at least 1 greater than all the other elements. So if total elements is 10, majority element is 6, and all the other elements are like 4 elements. So in this case as well, the majority element is greater than the sum of other elements. The sum is the number of occurrences. So this is the Boyer-Moore's boring algorithm. There is a candidate and both count. If both count is 0, it becomes candidate. And I'm going to work through the example. At first, both count is 0. Number 2 becomes candidate. And we increase the both count plus 1 since number is equal to candidate. So 2 has both count 1 and 2 appears again. It passed this because we already have one both count, and this both is for previous candidate as well, so it increased both count, and now both count is 2, and we get a both for new candidate, and since it is not same as the previous one, we decrease the both count, and again, since it is not for the previous candidate, we decrease the both count, and now both count becomes 0, and we get the both count for candidate 1 again, and since the both count is 0 right now, 1 is the majority and 1 becomes the new candidate, and 1 has one vote right now, and 2 comes again. We decrease the both count and both count becomes 0 again, and the last one is 2, and since both count is 0, 2 becomes the candidate, the majority element again. This works because majority element is always 1 greater than the sum of all the other elements occurrences. So at the end of this loop, we always get this single number, which is the majority element, which is the one greater, which always has the one greater number of occurrences than all the other numbers. Yep, that was my solution. And this has of n time complexity and of 1 space complexity. Yep, if you have any questions or comments, always feel free to write in the comment section. And thank you for watching.